Welcome to topic 3.1 on network fundamentals. In this lesson, we'll dive into the basics of computer networks, how they connect different devices, the various types of networks, and the protocols that make communication possible. By the end of this lesson, you will have a clear picture of how data moves around the world. So, we were going to have a look at various different types of networks in this. First of all, LAN, WLAN, and WAN, which are local area networks, wireless local area networks, and wide area networks. Then also slightly less common networks such as SANs, VLANs, and VPNs, which are storage area networks of virtual LAN and virtual private networks, which are known very well to the people of this school, as well as peer-to-peer networks. So, first of all, what is a LAN? It is a local area network, and it is one that connects computers in a relatively small area, like an office building or a campus. Because distance is small, the connection is usually faster, and the most common technologies are Ethernet cables or Wi-Fi within a building. Um, Then there is a wireless LAN, which extends LAN concepts wirelessly. While it's convenient because it eliminates the need for physical cables, it also raises security concerns. Encryption protocols like WPA2 or WPA3 are essential to protect data from eavesdropping. Now, a wide area network, when you connect to LANs across cities or even countries, you get a wide area network. It relies on leased telecommunication lines, satellites, or fiber optics, making it possible for companies and ISPs to connect users around the world. Now, there is also the concept of SANs, or storage area networks. They are a special network dedicated solely to data storage. So rather than dealing with file level access, it works at a block level, which improves performance, reliability, especially crucial in an enterprise environment and data centers, which is where you'll most commonly see it used. As well as this is a virtual LAN. It allows us to create multiple logical networks within the same physical switch infrastructure. This helps isolate traffic, improve security, and reduce unnecessary broadcast traffic on, for example, large corporate networks. Now, a VPN or a virtual private network, they create a secure tunnel over a potentially unsecure network like the internet. So companies use them so remote employees can access internal resources securely, and home users can often use VPNs for privacy or to bypass geographical restrictions, among others. Now, finally, a peer-to-peer network is a network in which every device can share its own resources without a central server, so it is somewhat of a decentralized network. It makes it easy to set up, but more challenging to secure and manage at a scale. So a common example includes a torrent file sharing network. So standards and protocols. Standards ensure that devices from different manufacturers can communicate smoothly. It is basically having like a baseline of things that have to work together. And a protocol is a set of rules, for example, TCP or IP, that define how data is formatted and transmitted. So common application level protocols include HTTP, web browsing, or SMTP for email. So OSI versus TCP IP models. So an OSI model is one with 7 layers, and TCP IP model is 4 layers. So once again, the OSI model is a theoretical framework with 7 layers, while the TCP IP model is a more practical one. Each layer performs a specific role, for example, addressing, error checking, or physical transmission. And understanding these levels will help us troubleshoot network issues more effectively. Packet switching. In packet switching, data is broken into smaller packets, each containing a header, payload, and a trailer. These packets travel independently and may take different routes to the destination. This method is efficient and ensures reliability through error checking and retransmission. A network topology defines the arrangement of devices in a network. So each topology has its pros and cons. For example, a star topology is reliable due to its central hub. But if the hub fails, the entire network is affected. A mesh topology will cost far more as each device is interconnected, but it offers excellent redundancy and security. Client server against peer-to-peer. So a client server model, a central server manages resources and services, ideal for a larger scale business. On the other hand, peer-to-peer networks are decentralized, with nodes sharing resources equally, which are commonly used in setups for file sharing, small setups in general. Network security ensures the integrity, confidentiality, and availability of data. Firewalls block unauthorized access, while encryption secures data in transit. Secure protocols like HTTPs are essential for protecting online communication. However, threats like malware and phishing still are significant challenges. And understanding bandwidth, latency, and throughput. So bandwidth is the maximum data transfer rate or something. The latency is the time delay in said data transmission, and throughput is the actual data transfer rate. Understanding these metrics can help evaluate network performance. Bandwidth is the theoretical maximum speed, latency is the delay, and throughput is the real world after accounting for overheads and interference. Every network relies on hardware. For example, modems, they will connect you to your ISP, while routers direct traffic. Switches perform the backbone of LANs, connecting the devices, and access points ensure seamless wireless connectivity. Each and every single one of these hardware components will ensure that your networks will be running completely smoothly. Thank you for listening, and I hope everything is clear after this presentation.